So here we have a piecewise function. The information we're given so far, the domain of the piecewise function is negative infinity to infinity. And the first thing we're going to do is we're going to graph the function, the piecewise function. So for a piecewise function, okay, we're graphing these sets of function in pieces. These parts right here, x less than 2, it's the restriction on the parabola x squared. It means it wants us to draw the parabola only when x is less than 2. And for this linear function down here, this linear function will apply, we'll draw it, but only when x is greater than or equal to 2. So we're going to draw these two in pieces, starting with x squared. So x squared is a standard parabola, but I want to draw this parabola when x is less than 2. So I can start here at the origin. Okay. And for a parabola, when you plug in 1, the y value is 1. So we'll go here. When you plug in 2, the y value is 4. But notice, for this restriction, it's less than, not equal to, just less than. So on the 4, we're going to draw an open circle. And if we continue here, due to symmetry, we also have the other side. Okay? So this is the first piece of the piecewise function. We drew the parabola with the restriction, only for x is less than 2. So notice we didn't go beyond after 2 on the x-axis. Now for the linear function 2x minus 3, likewise, it says we will draw this line if x is greater than or equal to 2. So notice negative 3 is our y-intercept. So just to kind of visualize where we are, okay, and we can apply a rise over run here. So for the rise over run, we'll go up 2 over 1. But again, this line doesn't apply yet, only when we're greater than 2. So we'll go up 2 right here. So now that we're on 2 on the x-axis, this says it applies when we're equal to 2. So I'm going to draw a solid line right here. And continue with your rise over run. Up 2 over 1. Up 2 over 1. And notice how I connect this line. This line applies only when x is greater than or equal to 2. Okay? So we didn't continue all the way down here because the linear function did not apply, only when we were greater than or equal to 2. So this is how we graph the piecewise function. We graph it in 2 pieces depending on the restriction. Part B, use the graph to determine the function's range. So when we're looking for range, we're interested in seeing what part of the y-axis does the function cover. What part of the y-axis does the graph cover? So if you notice down here, the graph doesn't cover the bottom part of the y-axis. Okay, that is not part of the range. The first part of the y-axis that is covered is right here at 0. So our range begins at 0. Remember, for domain and range, we're going from lowest to highest, lowest value to highest. So check and see what part is covered of the y-axis, and notice all the way up here through, we are covered. And this right here means that we continue. So if you continue up on the y-axis, where are we going? We're going to infinity. Now for infinity, we use parentheses. Okay, never bracket for infinity, we always use parentheses. But then you check and see, what do we use for the 0? And here, 1 or 2 things we can consider. When I plotted this line, this is a closed circle. Or if you consider the solid line here as well. Okay, if it's a solid line, we use bracket. Sometimes you'll see this dotted. And if you see this dotted instead, then you'll use the parenthesis. But here, solid line, closed circle, this is the range for the function.